Welcome to Maths with EJD. In this video, I'll be talking about two-sample t-test. The two-sample t-test, the two-sample t-test. I guess I want to change this to this, and maybe this to this. Okay. The two-sample t-test is a statistical method used to determine if there is a significant difference between the means of two independent groups. Okay, this test is particularly useful when comparing the means of two different populations or treatments based on random samples drawn from them. Now, let's look at the steps. What steps do we take? Steps for conducting a two-sample t-test. Okay. The first step is to formulate hypothesis as usual. Formulate hypothesis. Okay. So the null hypothesis H naught assumes there's no difference between the population means. So that simply means if mu1 is the population mean of the first population and mu2 is the population mean of the second population, that means that the null hypothesis is that u1 is equal mu1 is equal to mu2. That is, there's no difference between the population means, or there's no significant difference between the population means. And of course, the alternative hypothesis H1, or what you can call HA. You can use H1 or HA as you like. So this one is just simply going to say, this one is in two ways actually. This one is actually in two ways. So the alternative hypothesis H1 is in two ways. It could either be a two-tailed test. If it is two-tailed, H1 would simply be that U1 is not equal to U2. That's one way to go. Then if it is one-tailed test, so for a one-tailed test, right, there are two possibilities again. It's either that H1 is such that U1 is greater than U2. That means the population mean of the first population is greater than the population mean of the second population. Or H1 can be that mu1 is less than mu2. So in this case, you can have a two-tailed test or a one-tailed test. So two-tailed test is where mu1 is just not equal to mu2. We don't care which is bigger or which is smaller. But one-tailed test, you are specific about whether U1 or U2 is smaller or bigger than the other, right? So that is for one-tailed test. So after formulating hypothesis, right, the next thing you want to do is to collect data. And of course, as this is collecting data simply means uh you get information, right? So here you gather two independent samples, gather two independent samples from the population because it is a two sample t-test. So from the populations, okay? So in this case, let's assume we are comparing test scores of two different classes. Okay, so there we can have sample one. So we collect sample one, that is maybe from class A. So class A, their test scores. And for sample one, we have X1, which is 85, 78, 92, 88, and 75. That's test scores from from 5 students from class A. Then we have sample two. Sample two, let's assume that is from class B. And then the test scores are X2, that is 80, 70, 75, 90, and 85. So in that case, we have another set of 5 scores. So the next thing we want to do is to read as calculate sample means and standard deviations and standard deviations. Okay, so here now we start with sample means. So sample means. So the sample means are simply x1 bar and x2 bar, which is normal mean now. So x1 is summation of all x1 divided by n1. So an n1 is 5, right? So for the first one, we have 85 plus 78 plus 92 plus 88 plus 75 divided by n1, which is 5. So that is 418 divided by 5, which is 83.6. That's x1 bar actually. X2 bar is summation of all of x2 divided by n2. So again, that will be 80 plus 70 plus 75 plus 90 plus 85 divided by 5. And that is 400 divided by 5. And that gives you 80.0 or just 80. So now we need two S1 and S2. We need two standard deviations. So since we've done the sample means, so let's talk about the sample standard deviations. So I mean, these things are best done in tabular format. I mean the standard deviations. But here I'll just go straight. Okay. Oh, I can still do them in tabular format. Yeah, we can do that. So we have for x1, right? For x1, we have 85, 78, 92, 88, and 75. Okay, so now we can do x1 minus x1 bar all squared. Let's just square that, right? Um, mm, yeah, so let me do it this way. Um, okay. Yeah, let me do it this way. So this is x1 minus x1 bar all squared. So I'll do the subtraction here and the result will come here. So we can do the same for x2. So for x2 now, we have the values again. That's 80. Then we have 70. Then we have 75. Then we have 90. And lastly, we have 85. So like this. Of course, for this also, we can do the same. So we need something like this. So x2 minus x2 bar all squared. So we have all this. Yeah, so we know that for x1, right? Of course, for the standard deviation, we know the general formula for standard deviation would usually be uh, S equals square root of summation of x minus x bar all squared divided by n minus 1. So we now do that for each of the values. So here for for x1 minus x1 bar squared now. So here we have 85 minus x1 bar is 83.6. 83.6. So that's 83.6, everything squared. And that will be 1.4. Okay. So actually, this is 1.4 squared. So and 1.4 squared is simply 1.96. 1.96. Then the next thing is 878 to 78 minus 83.6 squared. Okay, so that will be minus 5.6 squared. Minus 5.6 squared is 31.36. Then the next one is 92 minus 83.6 squared. So 92 minus 83.6 squared is actually 8.4 squared. And 8.4 squared is 70.56. Okay, next we have 88 minus 83.6 all squared. So it is 88 minus 83.6 is actually 4.4. When you square that, you get 19.36. Then lastly, we have 75 minus 83.6 all squared. So 75 minus 83.6 is actually minus 8.6. Minus 8.6. And if it is minus 8.6 and you square that, you get 73.96. So that's that for x1. Now for x2, we have the mean to be 80.0. Okay, that even makes things pretty easy. So here we just have 80 minus 80 all squared. That's 0 squared, which is 0. Then 70 minus 80 all squared. 70 minus 80 is minus 10. Minus 10 all squared, that's simply 100, right? Then we have, this is so sweet because it's straightforward. 75 minus 80 squared. 75 minus 80 is minus 5 squared. That's 25. Then you have 90 minus 80 all squared. 90 minus 80 is 10 squared. That's 100. Then lastly, you have 85 minus 80 all squared. 85 minus 80 is 5. Square that, you get 25. So that makes it pretty easy when you have something like this. So the next thing is, of course, we know that we need the summations, right? We need, for instance, we need the summation of x1 minus x1 bar all squared. That is, sum up all this together. And for the first one, the sum is 197.2. This is 197.2. Then when you come here to and you sum up 1, 2, 3, 4, and 5. So that sum of x2 minus x2 bar all squared is actually 250. Okay. I mean, 125, 225, 250, basically. And with that now, you can get S1. Of course, we know it's actually small s, right? So that's S1 equals square root of the summation from x1 minus x1 bar all squared divided by n1 minus 1. So that is, okay, let me do it. Let me go down. So this is S1 equals square root of, that summation is 197.2 all over n1 minus 1. That is 5 minus 1 because n1 is equal to 5, just like n2 is equal to 5. So we have this so that S1 now is equal to square root of 197.2 divided by 4. So that S1 is square root. S1 is square root of uh you know, all of that together is approximately 7.07 actually. So, and then when you come to this other side, you have S2 to be the square root of the summation of x2 minus x2 bar all squared divided by n2 minus 1. So that is S2 equals square root of 250 minus 5, I mean all over 5 minus 1. And then that is S2, which is square root of 250 divided by 4. So, uh, interestingly, uh, how would it be the same? Mm, I think it's important to check some of these things. Um, okay, let me be sure of the first one. Square roots, okay, square root of square root of 197.2 197.2 divided by 4. Okay, that is approximately 7 point. This is approximately 7.02. Then S2, so that's square root of 250 divided by 4. 250 divided by 4. That's approximately 7.91. Approximately 7.91. This other one is approximately 197.2, right? 197. You may also want to check from your side to be sure. So this is approximately 7.02. Okay, so that's approximately 7.91. Right. So now that we have all this, we can go ahead and do the next thing. That is step 4. Step 4, we want to determine the test statistic. Determine the t-statistic. And the t-statistic formula is this: t equals x1 bar minus x2 bar divided by sp root 1 over n1 plus 1 over n2. And here, sp is the pooled standard deviation. So we can say that sp is the pooled standard deviation. Okay, which is given by this: sp equals square root of n1 minus 1 s1 squared plus n2 minus 2 n2 minus 1 s2 squared divided by n1 plus n2 minus 2. So this one is talking about the degree of freedom. That's n1 minus 1 plus n2 minus 1. So that's overall n1 plus n2 minus 2, like that. So that if you put the values now, so we have sp equals square root of n1 is 5 minus 1, s1 squared. S1 is like 7.02. 7.02 squared plus n2. N2 is 5 minus 1 again. S2 squared is S2 is 7.91. So we have 7.91 squared. Okay. All of this over 5 plus 5 minus 2. So SP is equal to square root of 4 into okay. So we have to square all that, right? 7.02 squared, 7.02 raised to power 2. So for this kind of work, right, you need the calculator that you're used to. Don't collect somebody else's calculator because you're going to get into trouble if you're not used to that particular kind of calculator. 49.2804, that's what this is, plus 4 into 7.91 squared, 7.91, that is 62.5681. Okay, all of that over 8. So SP now is square root of, we have 4 times 49.2804. That is 197. This is 197.1216 plus again 4 times 62.5681. That is 250.2724 all over 8. So SP, the pooled standard deviation now, is 250. So 197.1216. That is 447.394 divided by 8. So SP now is square root of, so now it's becoming approximated. This is 447 divided by 8, 447.394 divided by 8. That is 55.92425. Now we're interested in the square root. So if we do the square root of that, square root of 55.92425. So that is, SP is approximately 7.4783. So that is SP. So we still have some distance to go. So it requires presence of mind, really important. Okay, so now that we have SP, then we can go back to our T. So so now we go back to T. So I think the hardest part is that SP. So again, T is x1 bar minus x2 bar divided by SP. The SP we just calculated, SP square root of 1 over n1 plus 1 over n2. So that T now is equal to x1 bar, x1 bar, that was the first thing, 83.6, then 80.0 is the second one. So 83, this is 83.6 minus 80.0 divided by SP now is 7.4783. 7.4783, then square root of 1 over 5 plus 1 over 5, like that. So, of course, so, okay, let's just tidy that up. 1 over 5 plus 1 over 5 is equal to, SM is 5. That is simply 2 over 5 in short. That's simply 2 over 5. No need to even stress because the denominator is the same. So that part is 2 over 5. So T is equal to 83. Okay, 83.6 minus 80 is simply 3.6, right? That's 3.6 divided by 7.4783, square root of 2 over 5. 2 over 5 is 0.4. So t is 3.6 divided by 7.4783 times square root of 0.4. So t now is approximately 3.6 divided by 7.4783 times square root of 0.4 now is let's see, square root of 0.4. Square root of 0.4 would be 0.6325. Okay, so let's just do the rest in one blow. So t is approximately now 3 divided by 7.4783 times 0.6325. 0.6325. Okay, and that gives us the final result of 0.6342. 0.6342 is our test statistic. 0.6342. Okay, 0.6342. Now, the next thing is, so take note, this is one of the bases on which you're going to make a decision. So um, the next thing is to determine, we want to now determine for step 5, we want to determine the critical t-value. So determine degrees of freedom. Determine degrees of freedom. Okay, not yet critical, right? Determine the degrees of freedom. So the degrees, of freedom, df, for a two-sample t-test is calculated as df equals n1 plus n2. Okay, I think I want to write that separately for emphasis. So it is calculated as df, degree of freedom, equals n1 plus n2 minus 2. That means that df is equal to n1, which is 5 plus 5 minus 2. Normally, right? In fact, let me go to the basics. Let me go down to the key thing. So degree of freedom for each sample is n1 minus 1 plus n2 minus 1. Okay? So that means degree of freedom is n1 minus 1 plus n2 minus 1. So that the degree of freedom is actually n1 plus n2 minus 2. That's how we came about that. So that the degree of freedom will be 5 plus 5 minus 2, which is 8 in this situation. So that's for the degree of freedom. And then we go to the sixth stage where we find the critical t-value. Find the critical t-value. Okay. So here now we say depending on the significance level, depending on the significance level, which is commonly alpha equals 0.05. It doesn't have to be, it can be 0.01. These are the two common ones, or anything else for that matter. And whether the test, is one-tailed, or two-tailed. You know, one-tailed would mean if it is two-tailed, right, that means mu1 equals mu2. But if it is one-tailed, it can either be mu1 is less than mu2 or mu1 is greater than mu2. In that case, to be one-tailed. Here we are talking about two-tailed. And whether the test is one-tailed or two-tailed, so we now look up, the critical t-value from a t distribution, distribution table for degree of freedom equals 8. So if you follow that, we just know that the critical t value for alpha equals 0.05 and degree of freedom equals 8. I believe for a two-tailed test now. Okay, yeah. Okay. For a two-tailed test, test, for a two-tailed test, that's just saying mu1 is equal to mu2 or mu1 is not equal to mu2. So for a two-tailed test, the null hypothesis is saying that mu1 is simply not equal to mu2. We don't care which one is greater. So DF for a two-tailed test will be approximately, of course, you have to use, they are different, the tables are different, but you get the same result. I mean, they are different in the sense that the way you look them up may not be exactly the same. So get used to your own kind of table. So what we have is approximately plus or minus 2.306. Okay. So now that you've got the critical value, it's really important. So it is the critical t value and the test statistic that you compare together to make your final decision. Okay. So this t value, which is 0.63, and this one is 2.306. Okay. So we now head for the conclusion. So let's go for 8. Yeah, that should be okay. Oh, 7 is the decision rule. So we now go for the decision rule. So for the decision rule, right? So we know that if the calculated, t statistic, is greater than the critical t value. The critical t value is what you get from the table. So the critical t value or less than the negative critical t value, then we reject the null hypothesis. Well, that may seem a bit muddled, but the whole idea is that the absolute value of what you calculated, it has to be less than the critical t value that you got from the table for you to accept the null hypothesis. Okay? So, in that case, uh, so once what you calculate is greater than the critical value, then you have to reject. You have to reject the null hypothesis. But if it is less, then you accept. Or what we say on the other hand is you fail to reject. So let's go for the conclusion now. In conclusion, in this example, right? In this example, the calculated t statistic, which is that 0.6 something. The calculated t statistic is 0.6342. 0.6342 is actually less than the critical value that we got, which is plus or minus 2.306. That means that it lies within the range, right? So if you look, this is more like you have this range minus 2.306 and 2.306. So you see that this 0.6342 will be somewhere in between. It's somewhere in between the two. That's 0.6342. Once it lies within that range, then it is so we accept the null hypothesis. So we now say thus we fail to reject the null hypothesis. We fail to reject the null hypothesis. That's simply that we are accepting the null hypothesis, which means that the population means are exactly the same, something like that. So, okay, what will be the final decision? So, final decision, since you have failed to reject the null hypothesis, that means we've accepted the null hypothesis. So, the final decision will be that based on the calculations, based on the calculations and comparison of the t-statistic, with the critical value, we conclude that there is enough evidence, to suggest oh, there is not enough, sorry. There is not enough evidence, rather, there is not enough evidence to suggest a significant difference between the means of the two classes, okay? Therefore, we accept the null hypothesis. H naught, which says that mu1 is equal to mu2. As such, there is no significant difference between the test scores of the two populations. Okay, there's no significant difference between the test scores of the two populations. All right, so the two sample t-test is a powerful statistical tool, right, that allows researchers to compare the means of two independent samples. So by following a structured approach, including hypothesis formulation, data collection, calculations, and decision making based on statistical evidence, researchers can draw meaningful conclusions from their data. On this note, we come to the end of the two sample t-test. So you can take two different samples and conduct your own, do your calculations, and then check the degree of freedom and things like that to get the T critical value, and then compare the values and make your final decision. And that's how it goes. So if you have not subscribed to this channel, please do that. And don't forget to hit the notification bell so you can always get alerted each time a new video is released. And don't forget to comment, like, and share so that more people can have access to this great learning. So until I come your way again, keep studying and keep getting better. Bye.